A conductor is defined as a material that conducts or transmits heat, electricity, or sound. Some examples of conductors include metals, aqueous solutions of salt, graphite, and even the human body. Conductors contain mobile charged particles that are free to move through the conducting material. The ability for the electrons to move throughout the material is why when a voltage is applied to a conductor, it creates an electric current. The reason this works is because metals can easily lose or gain electrons opposed to many large organic molecules that make up insulators. An insulator is defined as a substance that does not readily allow the passage of heat, electricity, or sound. Common examples of insulators include rubber, glass, dry wood, and plastic. Since organic molecules that insulators are made of are often held together by covalent bonds and hydrogen bonding, the electrons are not easily lost or gained. Therefore, they are not free to move throughout the material, like in conductors. Now that we know the definition of a conductor and an insulator, how would each of these react near a charged particle? We know that in the presence of a charged particle, a neutral object or atom will polarize in order to attract the charged particle. Let's look at the conductor first. Since the copper block is neutral, it will do whatever it can in order to attract the nearby proton. The only thing the copper block can do is become more negative in order to attract the positively charged proton. Since the copper is a conducting material and the electrons are free to move, the copper block will then polarize in order to attract the point charge. The electrons move to the right, giving the block a negative charge on the face closest to the point charge. This polarization of the copper block then attracts the proton. Now consider the plastic block. Unlike the copper, the electrons in the plastic material cannot move. Despite the fact that the electrons can't move, the plastic will still do whatever it can to attract the positive point charge. Since the electrons can't move, the only thing the plastic can do in order to become more negative near the proton is for all the atoms inside the plastic to polarize. The electrons in the electron cloud of all the atoms inside the plastic shift towards the positive point charge in order to become more negative and attract it.